So I will take you through our journey, so to say, of implementing the zero tolerance policy that we have. In first instance, I thought, okay, I could also give a presentation and tell you that the last 2 or 3 years we never found any pathogen hit in the product and the environment. Would be a nice story, wouldn't it be? And but then I noticed the other presenters speaking about statistics, probability of detection, heterogeneous distributions, Jack and Frank telling about environmental monitoring, and if you never find something, maybe you didn't take the right samples and so on. So I thought, no, I will never get away with that story. So unfortunately, so there we go. Well, in fact, of course, aiming for zero hits, that's good. So targeting zero is always good, to have that policy. To achieve it, to really have zero hits, that's another story. So what do we need also to get rid of those last bugs that are there? A few pictures. I always like pictures. These are actually some years ago, not the best factories at that time, and these are typical situations that we have totally improved, like the one on the right with powder leakage because there is a seal which is tightened with some sort of tie wrap or something, so that's of course a no-go anymore. But also the other one where, it's a bit difficult to see on the picture, but it was in fact cleaning of an atomizer wheel, so spraying the milk to get powder, and that one was cleaned manually in the environment, so just splashing water that was then going via the floor to the drain. Well, that's if you would consider this should be a dry area, that's of course not exactly what you want. So this is luckily all changed. That's nice. So, okay, before I go more into the content, maybe a bit background. Maybe most of you know FrieslandCampina. So in a nutshell, to start with, we are now 152 years old. It's always a bit arbitrary when do you start to count, but in 1871, some farmers joined forces, and they started this farmer group, and that was then the start of the counting, and 150 years later we could have this celebration. Maybe what not all of you know, that we have also quite a lot of factories in Asia, also in Africa. In Asia, that started already from the 60s and 70s, so part of us as well. And of course, FrieslandCampina is it's merged. There have been several mergings from Frico Domo, Coberco, Campina Melkuni, and now all together from 2008. We are having a lot of brands, so brands are quite important for us also throughout the world. So some global brands, but also local brands, also typically in Asia. Some brands are really strong, everyone knows it locally. We are also, of course, in infant nutrition. I think one of the, not all the dairy cooperatives are also having this broad product spectra, like from cheese to fresh products, but also infant formula. So that's quite typical also. Okay, then back to the content. So we started, we had all sorts of initiatives, of course, to work on our food safety. But from 2020, we started really a program, so not make it, so to have a continuous thing. So it's not just a project, try to solve things, but now to keep it for the future as well. And the target are really on these 3 main pathogen risks. For our total product portfolio, we really think these are the 3 major risks. So that's Salmonella Chronobacter for our powders and Listeria for cheese. So that's why, these 3 pathogens that resulted also in our logo and our name for this program, Trident. You could say, okay, why is it important? I think it's also good for internal communication to have such a word, maybe even a logo, that all the communication that is around it, or monitoring results we share, or investments that needs to be done, we can say, okay, we relate it to Trident, and then everyone knows, oh yeah, that's this pathogen program we have. So a few results I also like to share. So first of all, Salmonella, it was a risk in specifically in some older factories, like I also showed on the pictures. In the last 5 years, we have had only one product hit, which was after severe flooding. Often Also, when I look back historically, salmonella in a product was really like Murphy's Law, that there could be some salmonella in an environment, and then with like things like flooding or people that need to open equipment for some reason, so then Murphy jumped in and you could have a hit. So of course also working on preventing that salmonella is present in the environment, that's the most important thing. So we improved a lot also in the environment the last years. So we now have very incidental, and also again we did some investments, quite significant. So on the left you also see the picture of what it was before and after. So this was typically an old floor that was also not well cleanable. You can see there are some points where dust can easily be collected, and you can imagine if there will be some water, then that could be a nice place for the pathogens to be present. So in this situation, a totally new floor was built or was put in. The tiles were removed. That's sometimes a question. Do you put a coating on top of an old floor? But we also know that depends a bit on the activities that's going on, that also a new floor, that can also, the coating can also crack. And then the old floor with all these terrible things inside that of course can pop up again. So in this situation it was decided to totally remove the tiles, which is already a risk in itself, to remove this floor where maybe some bugs are in. Right. This is our latest salmonella hit. And I show it also because I think it's also quite a positive story. Because you could say, is this? Are we happy with it? Of course not. You don't want to find it. From the other hand, I think the procedures were followed in a very nice way. So that's also what I like to show you. So what was done? They do their normal rounds with environmental monitoring, and they found a positive. Well, that's of course. We are not happy, but it was, although it was in a high care area, it was also quite far away from the production. So it was near the entrance of the drying tower. They did investigative sampling. So directly after the hit, they checked, and they took a lot of extra samples from the environment. They were all negative. And also after cleaning, also more intensive, and so it was not found afterwards. So that's nice. Then the RCA comes, the root cause analysis. Very important to know, okay, where could it come from? So also they had some links because besides testing for salmonella, also the Enterobacteriaceae were tested as a hygiene indicator. And maybe it's not so well visible, but they could see some spots with increased entero counts. So that was already giving a link. Then they checked further, and so what could it be? And then they noticed that there is at a certain point there is an air handling unit that was leaking. So that was on top of the ceiling, and they could see that there are some spots where leakages had occurred. So that's quite a logic root cause, right? So they did some sampling over there, could not find it, but it makes sense that could be the original cause. And perhaps people, because it was in a walking way, maybe they took it with their shoes eventually to this point where a sample is taken, or maybe with some cleaning tools could also be that they have transferred it. So like I said, are we happy? No, not really, of course. But from the other hand, it also shows that the environmental monitoring program is effective. You find something, you can act on it. The standards are adhered to. That's also very good, of course. And the cost could be removed. So in the end, I think this is why we do it, right? That's it seems like you are in control, so that gives confidence. Yes, what helped to convince the organization? Yeah, sometimes, of course, it's also about investments, and unfortunately, these things happen also in the news. But that helps sometimes also to convince the higher management also really to invest, because this is, of course, what we all want to prevent. For Chronobacter, sometimes people say, it's too difficult to totally get rid of it. It's always there, but also then you can say, okay, sit back and relax. It's always there, so we cannot improve. But then also, I think by having attention, by doing investments, and then you can improve. And I also think that these these issues that have been in the market, unfortunately, of course, but that helped also to convince management to invest. Well, what we did as part of the Trident program also to make a lot of standards. And we really try to make it very pragmatic and practical. I think one of the previous speakers also highlighted already that very important, if you find something, that you know what to do. So that's in the standard. I will explain a bit further. So some standards, but also on the lab, we wanted to make sure that our methods are all aligned. Also, we have, of course, labs in Africa and Asia, so they do also the pathogen testing. So that should all be done in a validated way. So that's also very important. And also the design of the lab. That where do you weigh the samples? Where do you if you use PCR, do you have different cabinets and so on? So that's more standardized, which is very good. So what I mentioned, so knowing what you should do after finding a hit, go to the Canva, important. I mean, I think in the past it was quite common that after a hit, people directly wanted to get rid of it, so took all the disinfectants they could find and spray to remove it, right? Makes sense, but not if you want to learn what the root cause could be. So then you need like a freeze situation, so go there, see if you should make it a restricted area, very important of course, to prevent that it's spreading further, but also first to take extra samples before you do cleaning and disinfection. Because if you do cleaning and disinfection, then you also destroy your potential evidence where it could come from. So that's also, I think, an important one in this standard. After cleaning and disinfection, then you do intensified sampling for a period of time, risk-based, to see if you're back in control. I also think that the way to do root cause analysis also improved. We have a structured method for it. I personally like a lot the is not approach, so you really can compare lines or situations and see, okay, what is characteristic of a certain period or characteristic of a certain line and things like that, and that could really give you a clue where the root cause can be. Also a stricter standard on environmental monitoring. So I know there are different definitions. Jack, you told about what it was in the US. We have some other definitions, but in the end it makes sense that also we have our product contact surfaces. For powder, we don't. That they are not in the environment. For cheese, we do have, like transport belts, for example, where cheeses are on. We call H1, which is really close to an opening. So I think that was your zone 2. And H2 for us, that's in the same zone, so typically in a high care area, so the same area as where your opening is, and H3 is in the next zone. So I think also in the past we focused a lot on H1 because there is the biggest risk for product contamination. So that was really the focus to prevent product contamination. In a way it makes sense. From the other hand, also Jack, you explained it, you also want to know, are these pathogens present in the environment? So it's not only about the risk to the product, but also you want to know if your cleaning procedures of the environment are effective, if your zoning procedures are effective. So you also want to know if these pathogens are really somewhere in the environment. So also look into some dusty places, some corners behind whatever you can think about. So that's crucial. So in the last years, we focus more on H2 points, so to say, because I think we also reduced the amount of H1 points, so to say, so to remove points where people can open equipment or so things like that. So we have less H1 points, so to say, and I think it's also, if you score quite well on H1, then it also makes sense to focus more than on H2. So that's also a way of thinking. Right, so we also have our internal trainings and procedures on sampling techniques. Actually, this is a few pictures I had from a cheese factory, also showing a bit the dilemmas, what you could face as a sample taker. Suppose you need to take a sample from the floor. Then what do you do? I mean, you can just pick an easy, clean-looking spot on the floor, or do you search for a spot where you can maybe see some fouling, and you can see also in the picture in the middle, there's this this thing standing on the floor that can accumulate dirt quite easily. So why not take the swab around this thing? Then you have, I think, a higher chance to find something than only swabbing the clean floor. So just as an example. Yes, also a standard on cleaning and disinfection. In a way, of course, we have our fluid bed areas and all those critical high care areas where the default way of cleaning is only dry. But we know that from time to time, also when you have sticky powder, you cannot only do dry cleaning. So then what to do? And we call it controlled cleaning and controlled disinfection. So very important, not just spraying, and it can come everywhere because you also introduce water by using, for example, cleaning agents. So to do it in a controlled way, that's very important. And also what kind of disinfectants are most effective? What are experiences of different locations to really exchange that knowledge as well. Vacuum cleaners also important because, of course, you suck up this powder. The powder is also tested. That's also, I think, an important part also of our environmental monitoring program. Like the powder that's and the dust you have in the vacuum cleaner. I think it's a very nice collector of dust and anything that can be present in an area. So that's. But then, if you find a positive, how to clean it or how to disinfect it before this becomes your big source and you spread it via the vacuum cleaner. So. And now in the last year, we also thought, okay, what is now really needed to make another next step? So to really target the zero. And so we made a new list we call the key requirement list, started this year. And we made some different chapters of what we think are really the most important risk factors when it comes to Salmonella Coronabacter contamination in the powder locations. Well, most important, water leakages. That is sometimes quite difficult to avoid, especially during CIP. Often you need to make manual connections, and so you are also partly dependent on the human factor. So technically, there are also some challenges really to totally get rid of water leakages. But in the end, I think it helps to set priorities. If we know, okay, these locations have a few open points, there are some non-negotiable points, so then, you can also present it in a quite clear way also to the management. This is what needs to be done. This is our proposal, and you decide on it. I think that gives the right discussions you want to have. So you could say, water leakages, we know it already for, I don't know, 10, 20, 30 years, so what's new? From the other hand, like I explained, this gives, I think, also for the management a very good list. Okay, this is our top priorities we should work on. And also, if there has been a few hits in the environment, and we know if a certain point is related to it, that gives also, of course, this priority. Because, there is this experience, like, oh, we have found something that plays. So good RCAs also help really to focus on those points. And what is also new is typing, so that's the bridge to this part. Luckily, the technique itself was already explained this morning, so that helps. For many years we do already MLST typing of our Coronabacter environmental hits. And I made an overview actually of some MLST numbers, so strain types. And it appeared that in 7 locations where we have found Coronabacter in the last years, that there were 6 strain types. They were all present in all these factories. Some even, which is now coded ST1 here, was dominated in 5 different factories. So that's from one hand also interesting. Could it be the same source, or are they different? So then if you want to know, then you need to go a level deeper. So then you come into the area of whole genome sequencing, or maybe the typer. So maybe in future, who knows? So what we did also for a few MLST types, we did whole genome sequencing. And we were also curious to see what could it bring. So for one MLST strain type, we picked 10 isolates and from different locations, and we tried to compare. And there we could see quite nicely that the locations, they had different strains, so to say. So the clustering that showed that they are really different, these strains. But from this location X, there were 5 strains. They were identical, so they had just a few SMPs different. So we can consider them to be identical. So for the factory, that's also quite important. We now know that the locations, they don't have, most likely not a cause-consequence relation, but also for the location, they can also prove that these 5 strains are really identical. So if they know, oh, we found it here, we found it there, it's quite likely that there is a common factor involved. So yeah, MLST is useful, I think, within a location, as we have now observed a few times with whole genome sequencing, because it seems to match within the location. So MLST is still our preferred test to do. But yeah, if you really want to go a step deeper, then whole genome sequencing could add something, but it's definitely more costly and time-consuming. Yes, so that brings me to the summary. So yeah, the zero risk, of course, does not exist. We have the zero tolerance policy, which is quite successful with the new standards, with the actions we take, so sharpening also the standards, so to say. It's also, of course, about culture, also dare to share. And that's also became much more important in our company. In the past, I think people didn't want to share, even not to other companies or factories. Like, oh, we have a hit and it's there, but you can of course learn from each other. So it's more open. We make graphs each month about hits, so that's then you really learn and can make steps together. Well, the environmental monitoring program, of course, it's essential because it gives you the first impression that something is there, so you can act on it. Well, what I mentioned, the root cause analysis tool, it's crucial to understand what the cause can be and the mechanism of contamination. Yes, the typing has brought us some insights, so that helps as well. At the moment, mainly the MLST. Well, working with this key requirement list, as I explained, that really helps to set the priorities of what is really needed to make this next step. And then, management can decide what to do. That's the end. So thank you for your attention.